Okay, so let's do it. Let's calculate the first order shift of the nth level. And we can just use this formula directly. Now we have to expand V in terms of things that act naturally on N, which is A's and A daggers. Now it's important not to change the ordering of these when we expand out the bracket. Now these terms, this term, this A will drop N by 1, and this second A will drop it by another 1. So you have the inner product between N and N minus 2, which is going to be 0. This thing's going to do the opposite. It's going to raise N twice, and so we're going to get the inner product between N and N plus 2. And so that's going to be 0. Because remember, these are orthonormal, so if you have different numbers, then the inner product is 0. This one's going to raise it by 1, then lower it back down. And this one's going to lower it and then raise it. So these are going to give non-zero things. That's obviously N, so it's going to give us an N. And this term here, if we look at it, it's going to give us a root N plus 1 going up, and then it will give us another root N plus 1 going down. So that will give us an N plus 1. And we can actually work that out using the commutator of A and A dagger if you want to. So the commutator of A and A dagger is 1. So I could replace this AA dagger with A dagger A plus 1, so it would be N plus 1, which is why it's N plus 1. And so there we go. That's the first order correction. So the energy, the new energy, is going to be just this. We know what this is. And if we take out the factor of n plus a half, and of course we have our order lambda squared corrections. So that's my claim. That's my claim that that's the new energy. Now, is that sane? First of all, its units are good. So all I've done is I've shifted it by a unitless parameter. So you'll note that lambda has no units there. So that's good. Second is, when lambda equals 0, it gives us the right answer. So that's good. And thirdly, we know the correct answer. So the correct answer ought to be, which if we expand that out to second order in lambda, this is the binomial expansion. And you can see immediately that those two are the same. So we have the same first order correction from both. So this is true to all orders, in fact. So this version here is true to all orders, but we can see that they are in fact the same. And if we went on and did the second order correction and the third order and so forth, we'd eventually tease out all the orders of correction out of here.